Hey folks, today we're going to go through worksheet 1 on stoichiometry mole-to-mole relationships. Alright, so we're going to move through this pretty quickly. It's pretty easy. Right. Carbon disulfide is an important industrial solvent. It's prepared by reacting carbon with sulfur dioxide. How many moles of CS2, so we care about this, how many moles of CS2 will be formed when we have 6.3 moles of carbon? 6.3 moles. Alright, we're asking how many moles of CS2. Alright. So let's try this. We start with the information that we're given, which is 6.3 moles of carbon, and we have to convert from moles of carbon to moles of CS2. And there are 5 moles of carbon, and there are 1 mole, that's a ratio of 5 to 1, moles of CS2. So we take the 6.3, we divide by 5, and we get 1.3 moles of CS2. How many moles of carbon are needed to react with 7.24 moles of sulfur dioxide? Okay, so now we need sulfur dioxide, which is 7.24 moles. And how many moles of carbon? So this is our unknown over here, and the CS2 doesn't matter anymore. So let's start with 7.24 moles of SO2. And the fact that these are on the same side makes absolutely no difference. All we're doing is using the same process. We started with moles of SO2, so we have to get rid of moles of SO2, so they have to go on the bottom, and we're trying to convert to moles of carbon. And we have 2 moles of SO2 to 5 moles of carbon, so we put in 2 moles of SO2 to 5 moles of carbon. So we're done. So we take the 7.24, we divide by 2, we multiply by 5, and we get a total of 18.1 moles of carbon. Right, because those cancel, so we're left with moles of carbon. Okay, let's do another one. Silver can be made according to the following equation. Well, the first thing we have to do is we have to balance our equation. So I've got 1 mole of silver on each side, but notice my nitrates, I've got 2 on the other side, so I have to put a 2 here to balance, which means I need 2 silvers over here to balance, and I have 1 calcium on both sides, so I'm good there. Alright, so now I have a balanced chemical equation, and I have 35.3 moles of silver nitrate. So I have 35.3 moles of silver nitrate. And how many moles of silver are produced? Well, you'll notice I have a 2 to 2 relationship. So that should mean the same, right? So let's try it to make sure. I have 35.3 moles of silver nitrate. And I have to convert from moles of silver nitrate to moles of silver. And I have a 2 to 2 relationship. So when I divide by 2 and multiply by 2, I do in fact get 35.3 moles of silver. Alright, how about this one? Well, of course I have to balance the reaction. Let's see. Barium I've got 1, oxygen I've got 3, carbon I've got 1. I am balanced, so all of my coefficients are 1. I don't need to write them, but I'm going to put them in there just so that you understand. So if we start with 23.4 moles of barium oxide, clearly whatever we're converting to is going to be the same number of moles, because we're going from 1 mole of barium oxide, that's mole, to 1 mole of carbon dioxide. So I have a 1-to-1 relationship, so I come up with 23.4 moles of barium, of carbon dioxide. Alright, well, this is a rather complicated equation here for car batteries. Let's see what we're looking for. We have moles of PbO2, that's here, and we have 34.3 moles of PbO2, and we're asking how many moles of water will be formed. Alright, so we start with 34.3 moles of PbO2, and we're going from moles of PbO2, and we're going 2 moles of water. And PbO2 is 1 mole, and the coefficient is 1, and the coefficient in front of water is 2, so I'm going to multiply by 2, and I will in fact get 68.6 moles of water. Now I do want to comment on something. I do have 3 sig figs here because I have 3 sig figs in my problem. Okay. So now assuming I start with the same amount of PbO2, so that's 34.3 moles of PbO2, how many moles of PbSO4, lead 2 sulfate, will be formed? Well, I am going from moles of PbO2 to moles of lead 2 sulfate. And PbO2, there's a 1 in front of that, there's a 1 coefficient, and there's a 2 in front of the PbO2. So I multiply this by 2 as well. Again, I'm getting 68.6 moles of PbSO4. Okay, let's keep going to see what the other ones hold on the second page. Ammonia is produced by reacting its elements with each other, so I have to go and balance this equation. And let's see, I've got 2 nitrogens on the left, so I have to have 2 on the right, which gives me 6 hydrogens, which means I need the 3 there. So I am now balanced. Alright, if I have 34.3 moles of nitrogen gas, that's this one, 34.3 moles, how many moles of ammonia, that's over here, will be formed? Alright, so I start with 34.3 moles of N2. And I have to convert from moles of N2 to moles of ammonia, NH3. And for every mole of N2, I produce 2 moles of ammonia. So I'm done. All I have to do is multiply that out. So that's going to be 68.6 moles of ammonia. Alright, I want number 6. Let's balance first. I've got 1 zinc, I've got 1 sulfate, I've got 1 barium, I've got 2 chlorines. I'm balanced. So everything is a 1. It's implied, but you can always write them. It doesn't hurt to write them. You have 32.5 moles of zinc sulfate. So I've got the 32.5. And it's trying to figure out how many moles of barium sulfate will be produced. So I have to get rid of moles of zinc sulfate and go to moles of barium sulfate. And since they're both 1s, we just put 1s there, so our answer clearly is going to be 32.5 moles of barium sulfate. Alright, how about this one? Let's see. Sodium 1, OH1, hydrogen. Oops, I've got 2 of those, so I have to put a 2 there. I have to put a 2 here. And that means I have to put a 2 there. Alright, let's try this again. I am using 41.2 moles of sodium. 41.2 moles of sodium. And I'm trying to calculate how much, what am I trying to calculate? How many moles of hydrogen gas. So I'm trying to figure that out in moles. So I have 41.2 moles of Na. Folks, notice I'm always writing down the units and the complete units, meaning I'm also including the chemical, because that's important. Moles of Na, moles of H2, because that determines what goes down here. And since it's moles of sodium, I'm looking at moles of sodium, and that's a 2. I'm looking over here for moles of hydrogen, and that's a 1. So I take the 41.2, I divide by 2, and I come up with 20.6 moles of hydrogen. Alright, number 8, last one. First, let's balance the equation. Let's see, we've got 3 carbons on the left, so we have to have 3 carbons on the right. We have 8 hydrogens on the left, so I have to have 4 waters. And that means that gives me 4 oxygens here and 6 oxygens there for a total of 10 oxygens. So a 5 goes there. Alright, so I now have a balanced chemical equation. I'm trying to figure out how many moles of carbon dioxide I have. And I'm given 54.9 moles of propane. So if I start with 54.9 moles of propane, C3H8, and I go and I get rid of moles of C3H8, and I go to moles of CO2, well, C3H8, that's a 1, so I've got 1 mole of C3H8 gives me 3 moles of CO2. I multiply that out, and I get 165 moles of CO2, which is a huge amount. And by the way, you'll notice it only has 3 sig figs, and that's because I was only given 3 sig figs for the problem. Okay, folks, that's it for today. If you need some help, come find us in class. We'll be happy to help you. See you soon. Bye-bye.